Hi, my name is Chuck Ladwig. This project is for my Electronic Engineering 530 DSP class at Oregon Institute of Technology Winter 21. So I purchased this new ELEC USB SDR dongle, SDR standing for Software Defined Radio. Came with an antenna and hooked up to my computer here. And the instruction was to enable FM and AM demodulation and audio. So I started with the software-defined radio literature that was given as an example. So here we have Simulink stereo FM radio receiver decoder. And we see the Simulink block diagram here. So what we have is the tuning parameters. Here I can change the frequency and gain for the tuner. This is representation of the SDR receiver itself, and that goes on to the FM demodulate signal. So then this goes to MPX filter, which is a notch filter that attempts to block out the 19 kilohertz pilot tone. And then we have some spectrum analyzers in line so we can take a look at that signal. And that moves on to the stereo FM demultiplexer. So being stereo, it'll carry two signals, left and right. And that goes on to the decoder and then into the output or the audio. So if I run this, let me take a second. So you can tell we're getting a signal here, and we're seeing that represented here in our spectrum analyzers. So we got the demodulated signal, the MPX filter, and then finally the modulated signal. You can notice some peaks here. This should be around, the filtering level, and you can see frequency. The problem right now is I'm having issues with this software. It's not getting a good signal, and I'm getting lots of static and noise. So what I did is stop this. I used other software that was available from Toolbox Download, and went ahead and loaded that. So here's the FM receiver. Generally the same blocks as explained before, but when I do run this one, let's just take a second. So this is again Simulink. We got our block diagram here. This is our center frequency gain into our RTL SDR receiver. And you can tell that the sound quality is much better. So just demonstrating here that I am able to get a good signal. So that is the FM receiver portion. Also had the AM receiver set up. A couple other interesting things. I'm sorry, going back to this other software. It has a frequency offset calibration, so you can get some data on your center frequency offset. As this runs, we'll see it comes up with the data, which should be an FFT, and we can see here my offset is around the negative 35 kilohertz, so I can adjust that with the ppm if I wanted to get a better accurate signal and maybe reduce the signal to noise ratio. Okay, stop that. So moving on to the AM portion. So going back to the literature that was given to us in the examples, go ahead and run this. So this is using a simulation. Having a hard time getting any signal on AM because the transmitters around here don't broadcast very much power, so I went ahead and decided to just use the simulation to show the AM. So you can see the information, the carrier wave, and then the signal on that wave coming in, and the FFT of the carrier wave, and the SLSB and SUSB signals. I do have a live presentation here, but again, I'm not able to pick up any channels here in my local area, so you'll see that what I get is essentially static, but we do have some data here. So we can see the receiver signal, DPF signal comparison, and time versus amplitude, and you can tell it's just noise, so I'm not getting a very defined signal here. But I am getting a signal, and everything does seem to work. Alright, thank you. Bye.